So what we are looking at today is we actually have two shapes that we're looking at. So again, what you see here is this hierarchy that we talked about the other day in terms of you've got the parallelogram at the top. So all of those properties of the parallelogram trickle down to the rectangle. We've already talked about that. Today, it's also going to trickle down to what we call the rhombus. A lot of people will call that a diamond. And I know that on our screen, it doesn't look great. The reason I say that, these sides are all supposed to be congruent for a rhombus, okay? Again, it's a little bit with the digital piece, but those sides are all supposed to be congruent. So the things that you need to keep in mind is all of the properties of a parallelogram. Let's kind of review that. So first off, because it's a parallelogram, opposite sides are parallel. So we've got that in that property. Opposite sides not only are parallel, they're also congruent. So we have that property. The other piece that's congruent are opposite angles. So we have those are going to be congruent. The other thing about the angles is that the consecutive ones are supplementary. And then the last thing are your diagonals bisect each other. That's all true for a rectangle, also true for a rhombus, which is what you see here. So all of those 5 properties of the parallelograms trickle down to the rhombus. Your new ones, a rhombus, by the way, you'll see here rhombi, that's the plural of rhombus. By definition, a rhombus has all sides congruent. Okay, some people think of it as kind of a slanty square. All of the sides are congruent. Now, one of the other two deal with the diagonals. One is that the diagonals are perpendicular to each other. In other words, they form a right angle there in the middle. And then the other piece is that the diagonals bisect not only each other, because it's a parallelogram, but they also bisect the angles. Okay, so what I mean by that is when you look at this, I'm going to go ahead and go to one of our shapes here. Here we've got a rhombus, and we're supposed to find the missing measures. Notice we don't have to worry about the angles for number 1. So if we look at just the measures, what you have going on here, let's make this as simple as possible. I'm going to actually just kind of outline this with this example, and then we'll get into the example specifically. So the great thing is because all of these sides are congruent, and because you have a right angle here and shared sides, all 4 of these triangles are exactly the same, all 4 of them. What I wanted you to think about is when you were little, and like, I don't know if you did this, but when I was little, you would take paint and then you would fold it. And so what I mean by that, you would take paint and then you would fold the paper and it would stamp over here and over here if you fold it along this diagonal. That's going to be true. And then if you look here and here, if you take that wet paint and fold it over that diagonal, it's going to be the same as here and here. The same thing with if you fold over that diagonal. Those pieces are going to be the same. Okay, so if we look at the segments, if JK is 12, if we know it's a rhombus, all of these sides will be 12. So we can go ahead and say JM is 12. We can say, well, that's it for right now, sorry. If we look at JN being 7, because it's a rhombus, we know that it's because it's a special type of parallelogram, we know that that diagonal is bisected. So if that's 7, the other piece here will also be 7. We can then also use the idea that because the diagonals are perpendicular, we've got right triangles all the way around. So if we are trying to find JL, we don't have to use the right triangle yet because JL is just that full diagonal. So 7 and 7 is 14. However, once we get to MN, we're going to use that right triangle. So if we look, we've got this is my unknown, this is my 7, and this is my 12. And so when I set up my Pythagorean theorem, 12 is the hypotenuse. And so when I go about solving this, 7 squared is going to give us 49. 12 squared is going to give us 144. And then I can go ahead and subtract that 49 from 144. And when I do so, I get 95 for my x squared, and then I would do the square root, and that gives me 9.75 here. Okay? And when we go on to look at MK, if this is 9.75, which is what we just found, so is this. And so MK, you can either add those together or multiply by 2, and you get 19.5. So again, we see this possibility that when we have right triangles, we are going to be using Pythagorean theorem. So we saw that with rectangles, we see that with the rhombus, we did not see that with the parallelograms. When you look at number 3 is very similar. we're going to get some information. So if RT is 22, that tells me each of the little pieces along RT are 11. So I'm going to go ahead and label those. If US is 18, I know each of the little pieces there are going to be half of that, so each of those are 9. So let's fill in what we know. BT is 11, UV is 9, and now it's asking us to go ahead and find one of the other side links that we don't have labeled. So again, what we have here is we've got a right triangle, and what we need to figure out then is this is 9, this is 11, this is our unknown, and we can go ahead and do 9 squared plus 11 squared equals x squared, and we can solve. So 9 squared plus 11 squared gives us a value of 202 when I add the two together, and then when I do the square root of that, I would get 14.2. Guys, I don't care if you round to the 10th or the 100th, it makes no difference to me. So if RS is 14.2, so is ST, and we're done. Okay. So again, when we're missing side links, go ahead and use that Pythagorean theorem if you can. All right. Number 4. Number 4 is what I want for you guys to do is not overthink it. Okay. So again, you have 4 congruent right triangles here, 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 and here. So what I have going on is if I have this is 38 here, so is 3, so is 4, so is 5. All right. Then we also have all of the angles at the other corners, so 7, 6, 1, and 2 are all going to be the same also. So let's go ahead and fill in the red ones, the ones that I circled. So 3, 4, and 5 are all going to be 38 degrees. Okay, and then we also know angle 8 relatively easily because since it's a right triangle, angle 8 is in the middle, so therefore that's going to be 90 degrees. All of those angles around the middle are 90. So here's what you have going on. You've got a 90-degree angle. I'm just going to look at this triangle here. You've got a 90 degree and you have that 38 labeled. So to figure out my other angles, I would use that triangle. I know it's 180 total, and then I would go ahead and subtract 180 minus 90 minus 38, and that gets us a value of 52 for angles 1, 2, 7, and 6. So again, I'm using my idea that we've got that triangle. In this case, don't use Pythagorean theorem because we're talking about angles. We use the idea that the sum is 180. All right. Moving on to this one. This is the same idea. It's just both the sides and angles combined into one example. So when we look at this, ZY is 34. So all of the sides are 34 because it's a rhombus. If WY is 38, I'm going to go ahead and label each individual piece in there. So this is 19 and this is 19. And so let's go ahead and just do our sides. So WZ is 34. VY is 19. ZV we do not know. So again, what we're going to use is we're going to use that right triangle. We're going to use Pythagorean theorem. So we've got x squared plus 19 squared. The 34 is my hypotenuse, so it's the one that goes by itself. So 19 squared gives us 361. 34 squared gives us 1156. And then I want to go ahead and subtract 361 from that, and I get x squared equals 795. And then I'm going to do the square root of that, and that gets me 28.2. Okay, and again, if that's 28.2, so is this. And so from z to x, it's going to be just twice that, or you would just add 28.2 twice, and you get 56.4. Okay, now just like the other day, I'm going to go ahead and erase what we have just to kind of keep things clean. Now that we look at the angles, z to x to y. So this angle up here in this corner is 34. So that means all of those angles at the corners are 34. If we look at the angles in the middle, we have a right angle going on there. And then if we were trying to figure out our other angles at the other corners, I'm going to use that triangle and I'm going to do 180 minus the 90 in the middle minus 34. And so when I do that, I get a value of 56. And so that's all of my other corners. Okay, so now what I have is now I have everything labeled. I just have to figure out what the question is asking for. So for the first one, WX to Z. So W to X to Z is that angle there at 34 degrees. Then I've got WVZ. W to V to Z. That's one of the angles in the middle. So therefore that one is 90 degrees. Okay, and then I'm going on to ZYW. So Z to Y to W. Oops, let me try that one more time. There we go, Z to Y to W, that's the big angle. So if we know each of the small angles are 56 at that corner, we're going to add 56 and 56. And when I add 56 and 56, I get 112. And then the last one here, X, Y, W. So X to Y to W is that angle in the corner. Therefore, that is 56 degrees. Okay? All right, so that is the rhombus. Now moving on to your square. Here's the thing. I'm going to go back to our hierarchy here for just 1 second. Your square is essentially underneath the rectangle and the rhombus. So that means every property that the rectangle and rhombus have also gets absorbed by the square. So everything from parallelogram trickles down, everything from rectangle trickles down, everything from rhombus trickles down. So that's what you see here. When you look here, this is because it's a parallelogram. The second grouping is because it's a special type of rectangle. And then the last one is because it's a special type of rhombus. That's where all of those properties are coming from. Now, the beautiful part about this is the more properties that's going on, the easier it is to figure out missing information. So let's look at number 6 here. We're just going to do number 6, and we're going to do it slow enough that we've got it going on. All right, so first off, we're going to talk about the angles first. I know that's backwards from what we usually do, but we know because it's a special type of rhombus, this angle here in the middle is 90 degrees. We also know because it's a special type of rectangle, this is 90 degrees. So the key is, since it's also a rhombus, this angle is bisected, meaning that 90 degrees divided by 2 gets us 45. And that's going to be the case for every square all the time, forever and ever. That if you have those diagonals, those little angles at the corner are all 45. 100% of the time, that doesn't change. Okay, so the only challenge really is to figure out what the question's asking for. So the first one is DAB. So DAB is our big angle at that corner. So therefore, 90 degrees. If we look at AEB, AEB is the angle in the middle. So therefore, that one's also 90 degrees. If we look at CBD, so C to B to D, that's one of the small angles at the corner. So that one is 45 degrees. And then we've got BAC, so B to A to C. That one's also in the corner. That one is 45 degrees. That's it. Okay, but so again, that pattern that you see there is 100% always the pattern for a square. All right, moving on to sides. Moving on to sides. You've got AD is 11. So this is 11, this is 11, this is 11. Always. All right. So right now we can figure out BC is 11. We can then work to find AC. So again, what you see here is you see a right triangle. So we've got 11 squared plus 11 squared equals x squared. And so when we add 11 squared and 11 squared, you get 242 equals x squared. And then we're going to do the square root of that, which gives us approximately 15.6. And so that's our A to C, 15.6. BD is the other diagonal, and because it's a special type of rectangle, those are congruent. And then EC is only half of that. So we're just going to divide that by 2, and we get approximately 7.8 for that component. Okay? So I'm going to ask you guys a couple questions about number 7. So just make sure that you're being intentional and really trying. Guys, that's it for the square and the rhombus. As always, if you have questions, feel free to ask. Hopefully you guys are good to go. Thanks.